Hello friends, let us start with the unit 7th, that is coefficient of dispersion. It is also called relative measure of dispersion. Relative measure of dispersion formula can be derived by the ratio of absolute variability to the mean value or by the percentage of absolute variability. This is another name of the relative measure of dispersion, that is coefficient of dispersion. We will study coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of variation. First is coefficient of range. It refers to the ratio of the difference between two extreme items of the distribution to their sum. Coefficient of range is equal to x maximum minus x minimum upon x maximum plus x minimum. This is the formula of coefficient of range. First example is calculate the range and coefficient of range for the following data values, that is 45, 55, 63, 76, 67, 84, 75, 48, 62, 65. First of all, we will write down all the values. Then we find what is the maximum value in the observation, that is 84. Minimum is the 45. Range is equal to maximum value minus minimum value, that is 39. Now find the coefficient of range. We will apply the formula of coefficient of range, x maximum minus x minimum upon x maximum plus x minimum. We will put all these values in this formula, and with the help of calculator we will do all these calculations and we will get the answer 0.302. Next is coefficient of quartile deviation. It refers to the ratio of the difference between upper quartile and lower quartile of a distribution to their sum. The formula of coefficient deviation of quartile deviation is Q3 minus Q1 upon Q3 plus Q1, where Q3 is the upper quartile and Q1 is the lower quartile. Another example of quartile deviation is coefficient of quartile deviation is calculate the value of quartile deviation and its coefficient from the following data. Row numbers are given, marks are given. It is an individual observation. So first of all, we will arrange the data in ascending order. This is the major point. Here n is the number of observation is 7, which is odd. So we will apply the formula of odd. That is Q1 is equal to size of n plus 1 by 4th value, which is equal to size of 7 plus 1 by 4th value. Then size of second value. Now we will see the series, which is the second value. Second value is 15. So Q1 is lower quartile is 15. In a similar way, we will find out upper quartile, that is Q3 is equal to size of 3 into n plus 1 by 4th value is equal to size of 3 into 8 by 4th value is equal to size of 6th value, which gives, again we will see on the in the observation, that is 40. On 6th position it is 40. Now upper quartile is 40. First we will find quartile deviation, because in the question we have given to find quartile deviation. So quartile deviation formula is 1 by 2 Q3 minus Q1, which gives the value 12.5. And then coefficient of quartile deviation Q3 minus Q1 upon Q3 plus Q1, which we have already found, 40 minus 15 upon 40 plus 15, which gives the answer 0.45. 45. Another is coefficient of mean deviation. So the relative measure corresponding to the mean deviation is called the coefficient of mean deviation, and it is obtained as follows. Coefficient of mean deviation about mean is mean deviation about mean upon mean, and if we are finding from median, then coefficient of mean deviation about median is mean deviation about median upon median. Another example is calculate the mean deviation about median and its relative measure for 7 numbers given below: 55, 45, 40, 20, 60, 80 and 30. We have to find out mean deviation about median. So first of all, arrange the data in ascending order, because in median the first step is all the observations arranged in ascending order. So this is the ascending order: 20, 30, 40, 45, 55, 60, 80. Now we will find the median first. How many observations are there? There are 3, 3, 6, 7 observations. So 7 is odd. So number of observations are 7. 7 plus 1 by 2th value, that is size of 4th item. Now we will see in the observation what is the 4th item, 1st, 2nd, 3rd and 4th, that is 45. Now we will make the table. First of all, we will write down all the observations, that is x, and we know that median is 45. So we subtract all the observation from 45, that is 25, 15, 5, 0, 10, 15, 30. Sum of all the observation is equal to 100. Find out about median. This is a discrete series, so we will apply the formula of discrete series. This observation is x, this observation is f, and we will calculate first cumulative frequency, and sum of the frequency is 120. First median, that is size of n plus 1 by 2th item, value, size of, sum of the frequency is 120 plus 1.2, size of, that is 60.5th item. So we will look at the CF column, that is 60.5th item is 70, it is nearby 70. So look at the CF column, and that observation comes under x is 55. So mean deviation about median, summation of f into x minus median upon n. Now we will put all the values in the formula, that is summation of fd upon n. Next table we will make mean deviation about median. These observations are x, again observations f. According to the formula, we need to find out first mode of d, that is mode of x minus 55. All the observations subtract from 55, and next column we will make frequency into mode of d. We will calculate all these observations and then sum of frequency f into d. First we will find MD, mean deviation about median, that is 2440 upon 120 is equal to 20.33. After that we will find coefficient of mean deviation about median. So mean deviation about median upon median. This is the formula of coefficient of mean deviation about median. So numerator is 20.33, which we have already found, and median is 55, which gives the answer 0.37. Cumulative frequency, that is in this. it lies in 117, cumulative preceding cumulative frequency is 77. That's why preceding cumulative frequency is 77, corresponding frequency of the 30 to 40 interval is 40. We will put all these values in this formula, and with the help of calculator we will find the median 37.25. Next, calculation proceeded for mean deviation about the median now. Again, first observations we will write down, second table is frequency, third table is mid value how we will find lower limit plus upper limit divided by 2, that is 0 plus 10 divided by 2, that is 5. Now we will find mode of D, that is deviation, mode of x minus 37.25, earlier we have calculated, that is 37.25 median, and again all these values subtracted from the observation, subtracted from 37.25. The next table we will make frequency into deviation. With the help of calculator we will find all these values. Sum of frequency is 212 and sum of FD is 3209.5. Then the mean deviation about median is to be computed by the following. Mean deviation about mean formula is sigma FD upon sigma F, that is 3209.5 upon 212 is equal to 15.14. Now we will find coefficient of mean deviation about median is equal to mean deviation about median upon median, which we have already found. 15.14 is the mean deviation about median and median is 37.25. With the help of calculator we will do all the calculations, that is 0.4064 is equal to 0.41, corrected to the 2 decimal places. Next is coefficient of variation. The coefficient of variation is the ratio of the standard deviation to the mean. The higher the coefficient of variation, the greater the level of dispersion around the mean, and vice versa. It is expressed as a percentage. The formula of CD is equal to 100 into SD upon mean, where SD is the standard deviation and this is the mean, is equal to standard deviation upon mean into 100. Example of coefficient of variation is the standard deviation and the mean of a data are 6.5 and 12.5 respectively. Find the coefficient of variation. Standard deviation is given to us, mean is also given to us. We need to find coefficient of variation. So we will apply the formula of CD, that is standard deviation upon mean into 100. Put all these values in this formula and we will get the answer, that is coefficient of variation is equal to 52% with the help of calculator. Next example is the total marks scored by 2 students, Satya and Vidya, in 5 subjects are 460 and 480 with standard deviation 4.6 and 2.4. Who is more consistent in performance? We have number of observation is 5 given. First of all, we will find the coefficient of variation of Vidya, and then after that we will find coefficient of variation of Satya. Total marks is given that is summation of x is 480. Standard deviation is 2.4. X mean is equal to summation of x upon n, means sum of observations upon number of observations, that is 480 upon 5. Mean is equal to 96. Next step is CV, that is coefficient of variation is equal to standard deviation upon mean into 100. That is 2.4 upon 96 into 100 is equal to 2.5. Now we will find the coefficient of variation of Satya. Total marks given to us, that is summation of x is 460. Standard deviation is 4.6. Mean is equal to summation of x upon n, that is 460 upon 5. Mean is equal to 92. Now we will find the coefficient of variation is equal to standard deviation upon mean into 100. Put all the values in this formula, and with the help of calculator we get the value of 5. So now we will check which coefficient of variation who is more consistent performance. So CV of Vidya is less than the CV of Satya. So Vidya is more consistent. When we check the consistency, then we will check the CV. If the CV is less, then Vidya is more consistent, because CV of Vidya is less, so it is more consistent. She is more consistent in 5 subjects. Next example is the mean and standard deviation of marks obtained by 50 students of a class in 3 subjects: mathematics, science and social science. Observations are given to us, that is subject mathematics, science and social science. Mean 56, 65, 60. Standard deviation of mathematics is 12, science is 14 and social science is 10. Which of 3 subjects shows highest variation and which shows lowest variation in marks? First of all, we will find coefficient of variation in mathematics. Mean is given to us, that is 56. Standard deviation is also given, 12. The formula of CV is standard deviation upon mean into 100, which gives the value 21.43%. Now we will find the coefficient of variation in science. Mean is given to us, standard deviation is also given. We need to find CV, that is coefficient of variation, is equal to standard deviation upon mean into 100. Put all these values in this formula, we will get 21.54%. Now in social science, mean is equal to 60, standard deviation is 10, is given. Now we find CV, standard deviation upon mean into 100. Put all these values in the formula. With the help of calculator, we do all calculations, that is 16.67%. CV of maths is 21.43%, CV of science is 21.54%, CV of social science is 16.67%. Question is, which of 3 subjects shows highest variation and which shows lowest variation in marks? So highest variation, CV of science is highest, so highest variation in science, and CV of social science is lowest, the lowest variation in social science. Next is uses of dispersion. First uses of dispersion is comparative study. It means measure of dispersion gives a single value indicating the degree of consistency or uniformity of distribution. This single value helps us in making comparison of various distribution. Very important point. Next is, the smaller the magnitude value of dispersion, higher the consistency or uniformity and vice versa. Second is reliability of average. A small value of dispersion means low variation between observation and average. It means that the average is a good representative of observation and very reliable. A higher value of dispersion means greater dispersion among the observation. In this case, the average is not a good representative and it cannot be considered reliable. Next is the control the variability. Different measures of dispersion provide us data of variability from different angles. And this knowledge can provide helpful in controlling the variation. Especially in the financial analysis of business and medicine, these measures of dispersion can prove very useful. Next uses basis for further statistical analysis. Measure of dispersion provide the basis for further statistical analysis like computing correlation, regression and testing of hypotheses. Next is the application of dispersion. A measure of spread, also called a measure of dispersion, is used to describe the variability in a sample or population. Next is measure of dispersion are used to estimate normal values of a data set. Measure of dispersions are important for describing the spread of data or its variation around a central value. Next is, it is usually used in conjunction with a measure of central tendencies such as the mean or median to provide an overall description of a set of data. Now the summary. We have four coefficients of dispersion: range, quartile deviation, standard deviation, mean deviation. Formula of quartile range is coefficient of deviation is x maximum minus x minimum upon x maximum plus x minimum. Coefficient of quartile deviation is q3 minus q1 upon q3 plus q1, and coefficient of standard deviation is standard deviation upon mean, and coefficient of mean deviation is mean deviation upon average. Thank you.